Okay, so this is a fun solve it that I figured I'd share with you because it's worth just trying this on your own as just a little bit of fun. Diagram shows the amount of money that each player starts with in a video game, and this is the same amount here as here. So what they're saying is what amount must be in the chest to make sure that this is the same amount as this. And I'll give you the answer in just a minute, but just take a minute and try and figure it out. So by crossing out with different colored markers the different um, equal amount coins. This is one, this is two, this is two, this is one, and this is five. Each of the matching colors is the same amount. You can see that what's left is 18 to be equal to what's in the treasure chest. Okay, I believe that probably made sense for you. So just a note here, it says in the solve it, which is the problem that you just did, you may have used reasoning to find the amount of money in the chest. In this lesson, you will learn to solve these problems um, using equations. So I'm going to show you how you can use equations in order to solve problems like this. And we're starting most basically with the one-step equations. There's one thing that you need to do, and we're going to really unpack exactly how you need to think about it so that when we become more advanced in our problem sets, you're going to be able to do that too. So equivalent equations are equations that have the same solution. So if you rewrite something, like for example, down here in the example, you have x minus 3 equals 2. If you added the same amount to both sides, 3 to both sides, this is an equivalent equation, meaning whatever is the answer for this is also going to be the answer for this. Okay? Now you can find a solution to a one-step problem using properties of equality. And also, and this is big, inverse operations. And we're going to get into this because you absolutely must understand that. Okay? And then that's to write a simpler equivalent equation. So addition property of equality basically says that if you have something that's equal, then you can add the same amount to both sides and it remains equal and it's an equivalent equation. Likewise with the subtraction property of equality, if you have something that's equal, A equals B, then if you subtract some equal amount from both sides, it's still going to be an equivalent equation. So you've done this and you've said, okay, what am I undoing here? What's happening to x that I need to undo? I need to undo this plus 3 with a minus 3 on both sides. And then you can simplify it and it will be equivalent. Okay? To solve an equation, you must isolate the variable. Isolate means get it all by itself and get just a single one of them there. So you do this by getting the variable with a coefficient of 1, okay, alone on one side of the equation, like x equals. X equals means 1x equals. There's one of them. If you don't see a coefficient, it is assumed to be 1. And you can isolate a variable using properties of equality and inverse operations. When we say inverse operations, we're saying what operation, add, subtract, multiply, or divide, for example, undoes another operation. Okay? Subtraction is the inverse of addition. When you solve an equation, each inverse operation should produce a simpler equivalent equation. The idea is to get simpler and simpler and simpler until you're done. For one-step equations, there's the one thing that you'll do. Okay, let's see how this plays out in real life. We're going to start out by using subtraction, which is the inverse operation for addition. As you can see in this problem, what is the solution to x plus 13 equals 27? You can see that what's happening to x is 13 is being added to it. So how do we undo this, which is happening to x and keeping it from being isolated? Okay, we need to undo plus 13 with subtraction, minus 13. So here's what they say. You need to isolate x. Start by writing the equation. Always, and this is big, if you're listening now, listen to this like it is absolutely must do, must learn. You must start out by writing the original equation as you see it. If you don't do that, you're not following proper steps. Okay? Then, next thing you do, you undo addition by subtracting the same number from each side. So you write the original equation, or the expression from the left side, rather, and then whatever it is at the very end, whatever it is that you're doing to it, we want to subtract 13 from both sides. So instead of saying minus 13 below, we're writing it on the same line. Okay? And then on this side, you have to do the exact same thing. If you do it to one side, you have to do it to the other. That's the mantra of solving equations. So you write everything that was already there, and then your minus 13 equals. You write everything that was already there, and then your minus 13. In the next step, you simplify. These two are inverse operations, plus 13 and minus 13. They cancel out to give you just x, and this simplifies to 14. So now you've got your solution, and you can box this. I will box it just because I think we should always be boxing our answers. And to do your proof, you're going to substitute that answer into the original problem to check it. And we're really going to formalize this in the next lesson. But you start with your original equation, and then you write parentheses wherever there was a variable, and you put in the parentheses whatever the value of x is that you believe it is. And as you can see, you said it was 14, so that's what we're putting there. And then you simplify the left-hand side and the right-hand side separately. This is already a single number, so you leave it alone. These two can be combined to 27. And then you compare the two sides and you say, do I get the same amount on both sides? If so, I did it right. Okay, let's have you do your got it problem here. Okay, sorry for the audio, but for solving the equation using addition, what you're essentially using addition for is to undo subtraction. So what do we do here? We're looking at what's the solution for negative 7 equals b minus 3. What we need to do is look at the variable and then say what's happening to the variable. Well, 3 is being subtracted from it. We need to undo that. If subtracting 3 needs to be undone, what's the inverse operation for subtraction? You guessed it, addition. And I know that you know that, but this is what you do. Okay? It says oh, by the way, always write the original equation. And then if you want to add 3 to each side, which you do to undo this minus 3, then you write what was already there, and then plus 3 equals everything that was already there, and then the plus 3. Okay, all on the same line. This is an equivalent equation, and if you have it all on the same line, then you are writing this is an equation, this is an equivalent equation, and then you simplify it, this is an equivalent equation. Putting plus 3 below it, plus 3, and then an equals line, get away from that. Okay, we want an equivalent equation, another equivalent equation, etc. Okay, and they say, how do you get started? Well, again, you're undoing operations, so you want to undo subtraction with addition, and specifically undo minus 3 with plus 3. Here's your got it problem. Okay, you are using multiplication and division properties of equality now. We did addition and subtraction. Now we're going to do multiplication and division. And these are the facts, and you might want to take note of them. The multiplication property of equality says that if you multiply each side of an equation by the same non-zero number, you get an equivalent equation. So if you have a equals b, then multiplying both sides by c, a times c equals b times c, since a and b were the same amounts, you're taking the same amount and multiplying it by the same thing. It's going to result in equal amounts. So what about here? This is a division problem, by the way. So it says x divided by 3 equals 2. What's happening to the variable? It's being divided by 3. What's the inverse operation for division? Multiplication. And what's the inverse operation for divided by 3? Times 3. So multiplying by 3, that will cancel out there, leaving just x, and then you will get this. These are equivalent equations. All you've done is multiplied both sides by 3. Okay? Division property of equality states that you can divide both sides of an equation by the same non-zero number. It can't be 0 because you're not allowed to divide by 0 in mathematics. But if you have A is equal to B, equal amounts on both sides, then dividing those equal amounts by the same number will give you also equal amounts. So 5x equals 20. What's happening to x? It's being multiplied by 5. What's the inverse operation for multiplication? Division. What's the inverse operation for multiply by 5? Divide by 5. So you divide both sides by 5, and these are equivalent. Notice it says that you're solving an equation using division. Why would you be using division? Because it's the inverse operation of multiplication. And when we look at the problem, what is the solution of 4x equals 6.4? We can see that x is being multiplied by the 4. Whenever you have the coefficient sitting right in front of the variable, then that's multiplication. So 4 times x is what that says. And so it's 4 times x. What's happening to x? It's being multiplied by 4. The inverse operation is to divide by that 4. Okay? So what does it look like? You rewrite the original equation and then divide both sides by 4. You don't put divided by 4 on the original equation. This sits there by itself without being modified. The next line, you rewrite it with your divided by 4. This and this are equivalent equations. You should never start modifying this right away. I need to see, and everyone needs to see, the original equation unchanged at the start every time. Okay? And then you divide by 4 both sides, and you get x equals 1.6. Okay, now you should be checking this, and we're again going to be, I'll be going over that next time, by rewriting the original equation and then plugging this number in for x and simplifying it to make sure that it truly does work. But we will be absolutely formalizing that next time. Okay. And by the way, there's a note here that says, how can you use a model for this? Well, you can think about it like this. 4 of these equals the total of 6.4, okay? So each one of these is some portion of the 6.4. In fact, you got to take that 6.4 and you got to divide it into 4 equal amounts and examine one section of it to find out what x is equal. That's how you can visualize it. Here's a got it problem. See how you do. Okay, why would you be using multiplication to solve the equation? Because you're undoing the inverse of multiplication, which is division. This says x divided by 4. Um, by the way, I just want to say before we go into this slide, if you are not understanding why the got it problem is the answer that it is, you should be asking me or asking a friend. I don't have full explanations for the got it problem solution, so you want to mark it and say, I don't understand how they got that problem, and you should ask. Okay, just want to point that out. Now, let's look at this. X is being divided by 4, and that's equal to -9. How can you visualize this? Okay, well, here you go. You can see that you've got this amount of x being divided into 4 parts, and you're seeing that each part then results in a -9. So how much was it that each of the 4 groups was -9? Okay, but how do we do it algebraically? We do the inverse operation of divided by 4, which is times 4. And you always start with the original equation, untouched. Second line, you do whatever you're doing. You write what is already there, and then what you're doing, times 4. You write what's already there, and then times 4, multiplying both sides by 4. This undoes that to give you x, and these multiply to be -36. Okay, here's your got it problems. Okay, this is where you've got to really put your thinking caps on. If there's something that's going to confuse you, it may be this. It confuses a lot of people. It's not that hard. You've just got to pay attention to what's going on. This is what it says. When the coefficient of the variable is a fraction, you can use the reciprocal of the fraction to solve the equation. Now I'm going to write down, well, first of all, I'm going to show you the problem, and then I'm going to discuss it. Okay, here's the problem. What is the solution of 4/5 m equals 28? I'm going to write this down and then erase, but check it out. Right now, you can think that m is being multiplied by 4/5. Okay, and how do you undo that? Well, you could divide by both sides by 4/5. You could have 4/5 m equals 28. Remember, you have your original equation unchanged, and then on the next line is where you do your modifying of the equation. Okay, and of course, if you divide by the same amount that you're multiplying by, that cancels out, so this would be an m. But what do you do here? Okay, I'm going to write it over here on the side. So we could say, okay, then that's equal to m. And on this side, what we've got is essentially 28 divided by 4/5. And there's a rule that says for division of fractions, you can, we talked about this recently, stay, switch, flip, or keep, change, change. You keep the first number the same, and you change to multiplication by taking the reciprocal of that fraction. Okay, so essentially, the same thing as dividing by 4/5 is times 5/4. So we could just as easily go back and we could say, okay, let's, instead of writing divided by 4/5, let's write times the reciprocal, because that's how you do division problems. Okay, and when you do that, if we took what we see right here and we wrote 4/5 m multiplied by 5/4 equals 28 multiplied by 5/4, okay, then what you get here is you're multiplying the coefficients, or the coefficient with this multiplier, and you multiply numerator times numerator and denominator times denominator. 5 times 4, 20, over 4 times 5, 20. And then, of course, m. And I'll worry about what's going on this side in a second, but just the idea here is that what's 20 over 20? That's equal to 1. And we don't write 1m, we just write m. We've isolated the variable. Okay? That's a critically important thing for you to understand, is that to undo the fraction that is the coefficient, you multiply by its reciprocal, because by doing that, it leaves you with 1 as a coefficient, and when you don't write 1m, you just write m. And if you are writing 1m, I'm going to tell you to stop, because that's not the conventional way or the standard way of doing it. Okay, so let me finish erasing all this for you, and then we'll look at what they said for the answer to this, which hopefully just reinforces what I was just telling you. So here we go. Okay, multiply each side by 5/4, the reciprocal of 4/5, and simplify again. This will cancel that out. And how do you do this then? Let's talk about that for a second. What we want to do is simplify this. And what we have is 5 over 4 times 28, essentially, right? And you can think of 28 as the same as 28 over 1, because any whole number you can put over 1 and it's equivalent. So now, if we want to simplify this fraction before we multiply, we can identify something on the top and something on the bottom that can be divided by the same thing. And both 28 and 4 can be divided by 4, resulting in 7 and 1. Now when you multiply across, 5 times 7 is 35, over 1 times 1 is 1, and we know that anything over 1 is just equal to that number, as we were just talking about. And that's where you get this from. Okay, so I know that seemed like a bit of a long explanation, but that hopefully will help you to understand why we're doing what we're doing and how to deal with it when you're doing something like this, where you're multiplying that whole number by the fraction. Because if you're not good at fractions, I can give you some coaching on how to do it. But ultimately, you're going to need to get comfortable with those fraction problems by doing a little bit of studying on your own. So here's your got it problem, and let's see how you do. Okay, one last problem here, which is an application of this idea. Toucans and blue and yellow macaws are both tropical birds. The length of an average toucan is about 2/3 the length of an average blue and yellow macaw. Here's the toucan, here's the blue and yellow macaw. Okay, toucans are about 24 inches long. What's the length of the average blue and yellow macaw? So the first thing we need to do is we need to say, okay, the length of the toucan is 2/3 of this length of the macaw. So if we want to give that a variable length to this because we don't know how long this blue and yellow macaw is, we can call it L, but you need to define the variable. You need to say, let L equal whatever it's equal to. In this case, the length of the average blue and yellow macaw. You can't just say blue and yellow macaw because we don't know about what. Are you talking about the weight or what? You got to say what you're talking about in terms of what you're measuring. Let L equal the length of it. So then what does that look like? Well, we know the length of the toucan is 24. We know that 2/3 of the blue and yellow macaw is what 24 is equal to. So 24 equals 2/3 of L. There's your equation. Now how do we undo it? Well, what's happening to L? It is being multiplied by 2/3. The inverse operation of that is to multiply by the reciprocal, 3/2. And then 2/3 times 3/2 is 1. So you get 1L or L. Now we know what the length of the blue and yellow macaw is once we simplify this. And just to be clear, in case you didn't know how to simplify that, you write 3/2 times 24, and that's the same as 24 over 1. You can cancel this out by 2 and say 1 and 12, and then multiply numerator times numerator, and denominator times denominator. And that's where they get the 36 from. Okay? So what we're doing here is we are actually doing a proof to check. Okay, let's check it. And this is what you're going to be doing eventually, starting next lesson actually, is we take the original equation, 24 equals 2/3 L. We write it on the first line. On the second line, we rewrite that exact equation with parentheses wherever the variables are, and then values substituted in. Okay, and then you actually verify by doing this math. These can be canceled by 3 to give you a 12 here, and 2 times 12 is 24. Checks out. So that is a proper answer for what L is equal to. Okay? So here's your got it problem. See how you do. Okay, hopefully that all made sense. See if you did get everything by trying these lesson check problems. Good luck.